Hello everyone, myself Saroni Tiwari and my roll number is 205054. So, today we are going to instantiate a topic that is vector space homomorphism and it is also called as the linear transformation. So, for that, what we're going to do is now let's suppose let u of f and v of f be the two vector spaces over the field f. Okay, we are letting that u of f and v of f be the two vector spaces over the field f. Now, what will be the mapping? The mapping of f, that is from u to v, is called the linear transformation. The topic which I've written over here, this is what the actual meaning is कि जो mapping होती है u से v तक उसी को हम क्या बोलते हैं, linear transformation बोलते हैं या फिर homomorphism of u into v. Now there are few conditions, there are two conditions for that, that is f of, the first condition is f of alpha plus beta is equal to f of alpha plus f of beta, and f of a of alpha is equal to a f of alpha for each a belongs to f and alpha comma beta belongs to u, and the a used here, it's a scalar quantity. The a used here is a scalar quantity, or in other words, f of a alpha plus b beta is equal to a alpha a f of alpha plus b f of beta for each a comma b belongs to f, where a comma b belongs to u also. Now v is called in this condition the v is called the homomorphic image of u. Now what do you all understand by the kernel of homomorphism? So what the kernel of homomorphism is, let f be the homomorphism of a vector space and u of f in your vector space u of f into a vector space v of f. Okay? Then set k of all the elements of u which are mapped into the zero. Remember, it's zero, only the zero element of v, then that is called the kernel of homomorphism. Okay, let me illustrate with you one example. So let's see. Let's suppose this be this be u of f, and let's suppose this be v of f. Then those elements of u of f which will be mapped to the elements of 0 of v of f, the elements which will be mapped, the elements of u of f which will be mapped with the 0 element of v of f, then those all elements will be called as the kernel. इन्हीं को हम क्या बोलेंगे, kernel बोलेंगे. Now let's back to that topic. There is one condition also that k is equal to alpha belongs to u, and where f of alpha is equal to 0 dash. जहाँ पे 0 dash क्या है, 0 vector of v. That what I showed to you. Now the next is range and null space of linear transformation. What it is? Let u of f and v of f be the two vector spaces and t be the linear transformation from from u into v. Then the image or the range of t denotes as the r of t, that range is called also called as r of t, is set of all the vectors b that belongs to v such that t of alpha is equal to beta for some alpha belongs to u. Let us see over here. So let again draw u of f and v of f. Then what the next is? Let's suppose there is an element alpha. Okay? Then and it is mapped with v of f, and let's suppose it's mapped with the beta. Then u of alpha and v of alpha here are the two vector spaces, and t is the linear transformation from u to v. From u to v, t is the linear transformation. Then the image or the range of t denoted, then the image or range of t denoted is called r of t. What it's called? It's called r of t. जो इस एलिमेंट की जो इमेज होंगी जो ट्रांसफॉर्मेशन के थ्रू लिंक्ड है वो हमारी r of t कहलाएंगी. एंड इनका रिलेशन क्या होता है कि t of alpha is equal to beta for some alpha belongs to u. R of t is equal to beta v, that is t of alpha is equal to beta for some alpha belongs to u. Yeah, and null space of t is denoted as n of t is the set of all the vectors alpha belongs to u, that is t of alpha is equal to 0. Let me show you here what I said. Let me again draw the u of f V of f. Now for the null space, and let's suppose alpha be the element here and it is mapped with V of f through 0 dash. If it is mapped with V of s through 0, not 0 dash, it's 0, then this T of alpha, then T of alpha is equal to 0 and T of alpha is equal to 0, and जो हमारा U of alpha का जो डायमेंशन होगा, जो इसका डायमेंशन आएगा हमारा, दैट इज कॉल्ड नलिटी, एंड जो इसका डायमेंशन आएगा उसको हम क्या बोलते हैं, उसको हम रैंक बोलते हैं. तो अभी अब आगे हम रैंक एंड नलिटी देखेंगे. तो यहाँ पे जो U of alpha का जो डायमेंशन होता है उसको हम नलिटी, उस U of alpha का जो डायमेंशन होता है उसको हम नलिटी बोलते हैं, एंड V of alpha का जो डायमेंशन होता है उसको हम क्या बोलते हैं, उसको हम वो बोलते हैं, रैंक बोलते हैं. Now what I was telling you there is the rank and nullity of the linear transformation. Let T be a linear transformation from vector space U of f into a vector space V of f, where U of f is a finite dimension vector space. Then the dimension of range of T is called the rank of T, and it is denoted by rho of T. That is, rho of T is equal to the rank of T, and that is equal to the dimension RT. And the nullity of T is defined as the dimension of null space, of T denoted by V of T. That is, V of T is equal to the nullity of T, and that is equal to the dimension of N of T. Thank you everyone. Thank you so much.